All right, so in this video, I'm running through the very initial stages of making a sketch that eventually I'll turn into an object-oriented sketch. For now, I'm just working with a really rough prototype of what will eventually become one object, and I want to get some of the behavior that I'd like figured out. It'll make it a lot easier down the road once I turn this into a class template and make a lot of duplicates of it. So what I'm working on here is this sort of eyeball shape that we've looked at in several of the demo videos for this week. And I'm trying to get some behavior that I'm sort of mimicking here, where I've got two concentric circles. And they're not actually concentric, but one circle inside of another circle. So you can see I've got this black ellipse that I'm drawing at the mouse location. And what I'd like the behavior to be is, for it to move around within the larger white ellipse, but to stop when it gets to the edge. So right now you can see, of course, I'm just using this line, line 13 here, or actually it's line 12, to draw that ellipse wherever the mouse happens to be. So there's nothing stopping it from going beyond the boundaries of the white ellipse right now, but that's what I'd like to figure out in this video. And so there's probably many different ways we could do this. My plan now is to try to get the angle between the mouse and the center of the larger white ellipse. And that's going to help me figure out how to constrain the smaller ellipse, to within the bounds of that larger white ellipse. And you can see in my sketch here, I've got this black ellipse. I've also got a line drawn in between the center of the white ellipse and wherever the mouse is. This is just kind of helping me to visualize what are all the different factors that are happening in the interaction that I've set up so far. My goal here is to get the angle between the mouse and the center of the circle. And so to do that, I'm going to first set up a variable that will hold my angle. And I'm just going to call this angle. So down here, I'll initialize that angle, and I'll do it using the atan2 function. So this is a math function that's built into JavaScript, and this is going to give us the 4-quadrant inverse tangent of the angle that's formed between 2 points. And the angle that I'm looking for is the one that's formed by the line on the screen. And so the way that we do this is we take our 2 points, we subtract the y coordinates from one another, and we subtract the x coordinates from one another. So we'll be feeding in 2 points to this atan2 function, and the first one's going to be the difference between the y coordinates. So I'll say mouse y minus, and then I would put in the y coordinate of my larger ellipse. So in this case, that's width over 2. So rather than just copying and pasting that static value, I'm going to also make this into a variable, and I'll just call this iy, and I'll initialize that in setup. So that's giving us the first component of that inverse tangent function. The second one is going to be the difference between the x coordinates of the mouse position and the center of the ellipse. So I've got the center of the ellipse being set right now with a static value, height over 2. I'll go ahead and make myself a variable to hold that value. That way I can move those things around. And then I can populate my second part of the inverse tangent function by saying mouse x minus ix, which is the center of my white ellipse. So I'm calculating that angle. Right now, I need to do something with that angle variable. I'll just go ahead and print it to the console. So I can see I'm getting the angle in radians. And I can make this a little bit easier to understand if I wrap that radians angle in the degrees function. So here I can get 0, roughly 90 degrees, roughly 180. This should be either 270 or negative 90, and then all the way back to either 0 or 360. So we're getting that same range of angles that we would use, say, when we're drawing an arc. So maybe I could, just to sort of play around and see how this is operating, maybe I could go ahead and draw an arc and use the same center point as my white ellipse. And let's give this a fill color. Make this orange. Oops, I forgot one argument here. So there you can see I'm able to use that angle measurement to draw out an arc. So that's a big step in the right direction towards what I wanted to figure out. So basically I can get the angle between the center point of my ellipse and wherever the mouse happens to be. And using that, I can figure out a point along that line formed between the center point of the ellipse and the mouse, and figure out where my black ellipse would need to live along that line. So the other piece of information I'll need is the distance that this smaller black ellipse can go before it hits the edge of the white ellipse. So I'm going to go ahead and make a variable to hold that. And I'm going to call this on I dist, short for on I distance. So basically, how far away can the black ellipse be from the center point, and still remain completely within the white ellipse. So in setup, I'll figure that out. It's basically just the difference of radius between the white ellipse and the black ellipse. And so while I'm at it, I'll need a couple variables to keep track of how wide the white ellipse is and how wide the black ellipse is. So I'll make one called pupil diam for the diameter of the black ellipse, and then one called white diam for the diameter of the white ellipse. And let's go ahead and set these up. I'm just basically taking all of the hard-coded values that I started out with and transferring those into variables. And that way I have one central place to start controlling all the features of my sketch here. Okay, and then for pupil diam, let's see, looks like I've got that set to 50 where I'm drawing the black ellipse. Okay, great. So what I need to do now is figure out the difference between the radius of the white ellipse minus the radius of the black ellipse. And so I just need to do a little bit of math to figure out that on I dist variable. So I'm going to start by figuring out what is the radius of the white ellipse. And right now I'm setting a number that's the diameter. So I know the radius is going to be half whatever that number is. So white diam divided by 2 minus whatever the radius is of the pupil. And same deal. We've got this pupil diam variable holding the diameter of the black ellipse. We cut that in half. That gives us the radius. Okay, so it's going to be that combination of the on I distance variable along with the angle that we're figuring out down here with the inverse tangent function. It's the combination of those two that's going to let us figure out where we need to place that black ellipse. And while I'm at it here, I'm just going to get rid of this arc. I don't actually need that. I just kind of wanted that for visualization purposes. And so the way we're going to do this is we're going to take that angle and that on eye distance, and we're going to convert those two pieces of information into XY coordinates. First of all, we'll need to make some variables that are going to hold the X and the Y location of our black ellipse. So I'll call these PX and PY. And so in our draw loop, we'll calculate what PX should be by taking that on eye distance and multiplying it by the cosine of whatever our angle is in between the mouse and the center of the white ellipse. And then similarly for PY, we'll take that on eye distance, multiply it by the sine of whatever our angle is. So that conversion is going to give us an X and a Y location, and that's where we should place our black ellipse. So for now, I'm just going to comment out that ellipse. And let's do another one right here. And this time we'll use PX and PY. And we will use the pupil diam for the diameter. So I can see that's sort of working. What I need to do though is to take into account the fact that that PX and PY that we're calculating are in relation to the center of my white ellipse. So I need to add those. So there you go. I've got that black ellipse placed right at the edge of the white ellipse, and it's following the angle wherever that mouse happens to be. So it's about half of the interaction that I want. The rest of what I'd like to tackle is I actually want some different behavior for that pupil when the mouse is inside the white of the eye. So it makes sense when the mouse is over here for the pupil to be right up against the edge. But when I'm moving the mouse here in the center, I don't want this kind of like flipping operation. So let's see, we can rearrange some code here. I don't need that line anymore, or that commented out ellipse. And so basically what I can do here is set up a conditional, and I can have this set of behaviors for when the mouse is outside the white ellipse, and I'd like to make a different set of behaviors for when the mouse is inside the white ellipse. So let's go ahead and set up a conditional. And so what I'm testing for here is how far away the mouse pointer is from the center of the white ellipse. And I can figure that out pretty easily by using the dist function. So this gives me the distance between 2 points. You could also think of it as a function that gives you the length of a line that's in between 2 points. And so our first point is going to be the center of the white ellipse, so that's IX, IY. Then our second point is going to be wherever the mouse is, so that's mouse X, mouse Y. And so I'm thinking we could test for if that distance is greater than the diameter of the white. Then we'll do this set of behaviors. Whoops, and I should adjust this because that's giving me the diameter. I actually want to check the radius. So you can see I'm good, and I'm getting that, pupil coming right up to the edge as long as my mouse is outside the edge of the white ellipse, but when I'm inside of it, I don't see the ellipse anymore, right? Because that is all enclosed in this part of the code block there. So let's add an else statement for presumably when the mouse is over the ellipse. And in that case, we can just have the ellipse directly follow the mouse. So let's see if that works. Whoops. Not quite. You can see this is so close, but not exactly what I was thinking. And basically what's happening here, we're not taking into account the diameter of the pupil. So we need to change this around a little bit. I'm actually going to get rid of this conditional and we'll start from scratch. So I think it actually makes more sense to use this on iDistance variable as our radius that we're testing against, because that's already taking into account the radius of the pupil. So let's go ahead and say if the distance between ix and iy, so again that's the center of the white ellipse compared to the mouse position. So if that's less than that on iDist, then we know we are inside of the white, and even beyond that, we're inside enough to take into account whatever the radius of that pupil is. So then we should have an ellipse that just follows the mouse. Whoops. And else, so that should mean that the mouse is outside of the bounds of the eye. All right, so that makes a little bit more sense. And we could think of this as doing that same initial conditional, the difference being that we're not testing for the radius of the white, we're testing for the radius of the white minus the radius of the pupil. So that way we can come right up to the edge, and once the mouse leaves the eye, the white, then the pupil's going to stick right to the edge. As soon as we are inside the white of the eye and inside the radius of the pupil, then we're going to follow directly. So we get that really seamless transition between the two behaviors. So this is pretty much a basic prototype of the behavior that I want to translate into my template class. And this is a really common way of working, is just starting a really small prototype sketch, literally in terms of it being a sketch, getting the behaviors that you want, doing problem solving, kind of breaking things down before you jump in and try to do kind of more complex parts of the code.